And today we're going to talk about how metals and non-metals react together and the reason why they react in such a way. Now, if you do remember, the reactivity of an element depends upon the number of electrons, and more specifically the number of electrons in the outermost shell. And you might have also learned in grade 9 that the noble gases are non-reactive because they have a stable octave. That means they have a completely filled outermost electronic shell with 8 electrons. Leaving aside helium, which has only 2 electrons completely, and hence it has only 2 electrons in the outermost shell, which is the only shell that it has. So let's have a look at the noble gases and their electronic configuration, and let's understand this octave. Now, looking at the noble gases, you have helium. Helium has only 2 electrons in total, and hence it has only 2 electrons in its outermost shell, which is the K shell. Now, let's talk about neon. Neon in totality has 10 electrons, and hence its electronic configuration is 2, 8. And if you look at it, you have 8 electrons in the outermost shell, which is the L shell. Now, argon has 18 electrons in total, and hence the electronic configuration is 288, and it has 8 electrons in the outermost shell, which is the M shell. Now let's compare this with the metals. In the metal we have sodium, which has 11 electrons, and hence the electronic configuration becomes 281. Look at it closely. You have 1 electron in the outermost shell, which is your M shell, which makes it highly reactive. Now, magnesium is next. Magnesium has 12 electrons in totality, and hence 282 is the configuration. It has 2 electrons in the outermost shell, which is the M shell. Then aluminium, which has 13 electrons, has a configuration of 283 and has 3 electrons in the outermost shell. Potassium has 19 electrons in totality, and you have 2881 as the configuration. And if you look at it, you have 1 electron in the outermost shell, which is the N shell. The calcium has an atomic number of 20, that means it has 20 electrons, and hence the configuration would be 2882, wherein you have 2 electrons in the outermost shell, which is the N shell. But if you can compare this with helium, you would understand that they both have 2 electrons in the outermost shell. Now, one thing that we need to understand over here, that the 2 electrons of helium are in the K shell, which has a capacity of maximum 2 electrons. But the N shell has a maximum capacity more than 2 electrons. And as per the theory of octave, we need 8 electrons in the outermost shell so as to make it stable. Now let's look at the non-metals, when first would be nitrogen with 7 electrons, and hence you have 2, 5, which is your electronic configuration with 5 electrons in the outermost shell. Then you have oxygen. The number of electrons are 8, 2, 6 is the configuration. Then you have fluorine with atomic number of 9, 2, 7 being its configuration, with 7 being the number of electrons in the outermost shell. Then you have phosphorus, which has 15 electrons in the outermost shell, and hence you have 285 as the electronic configuration with 5 electrons in the outermost shell. Then sulfur, you have 16 electrons, 286, which is the electronic configuration, and you have 6 electrons in the outermost shell. Then chlorine with 17 electrons in totality, and the electronic configuration being 287 with 7 electrons in the outermost shell. Now let's compare these non-metals to the metals. Now when you compare them to the metals, you can see that the closest way to get to octet in metals is losing an electron or a few electrons. But in the non-metal side, you have to gain electron in order to reach the octet, and that is the closest way in non-metals. Now this pretty much explains why you have metals which have a positive charge and why do we have non-metals with a negative charge. Now let's take an example of sodium from the metal side, which has 11 electrons in totality. Now the electronic configuration of sodium is 281. You have 2 electrons in the K shell, which is the innermost shell. Now why do we have 2 electrons in the innermost shell? Because of the capacity. And why do we have this capacity? This capacity is due to the simple formula of 2n square. Now wherein n is the shell number. So you have the first shell, which is the K shell, and hence 2 times 1 square would make it 2. Then you have the second shell when you have 8 electrons. And 8 electrons is again due to the maximum capacity. So you have 2 times 2 square, which makes it 8 electrons. And then you have the outermost shell, which has a capacity of 18, but due to the octet rule will have only 8 electrons. But in the case of sodium, you have only 1 electron. So we have 2 choices. Either sodium flicks off this electron, or it gains more electrons, which is 7 in number, and makes itself negative. Now the simplest way out here is losing an electron, as we have already said. The reason being that there are 11 protons in the nucleus of sodium, and we have 11 protons because the number of protons will always equal the number of electrons so as to balance the charge. And 11 protons to hold on to 7 extra electrons, it is a hell of a job, and it requires enormous amount of energy, and hence it is not possible.